Here we have two vectors a and b. Suppose we want to find vector a minus vector b. Well, we could think of that as vector a plus vector minus b. Now in a previous video we saw that vector minus b points in a direction opposite to vector b. It's parallel but opposite in direction, and it also has the same magnitude. So we just switch the direction of vector b, keeping the magnitude, and here we have vector minus b. If we move vector a over parallel to itself so that the head of vector a coincides with the tail of vector minus b, then if we want to add these two vectors, a plus minus b, we just apply the triangle law, join the tail of vector a to the head of vector minus b. How does this thing compare to a plus b? Well, we could complete this parallelogram here. Draw a line parallel to this line here and make sure it has the same length as this line. Now this will be vector b. Okay, this vector is pointing in a direction opposite to minus b. Vector a, of course, has the same, is just this vector here. It's pointing in the same direction, same length. So we've just completed a parallelogram. Now to add vector a and b, we can just use the parallelogram law, which means that we join this diagonal. Now, of course, we could have also gotten this vector by the triangle law. We could draw in vector b like this. Here's vector b. Well, it coincides with vector minus b. Join the tail of a to the head of vector b. And as you can see, it's the same thing, get the same result as the parallelogram law. But you can see that the sum of two vectors is one diagonal of the parallelogram formed by the two vectors when you put their tails together. And a minus b is the other diagonal. So if this vector is a minus b, what about the vector b minus a? Well, b minus a is just got by minusing a minus b. But if we minus a vector, we just switch its direction. So if we minus this vector, we get this vector here. Coincides with it, with this line, but it's pointing in the opposite direction. So this brown vector is b minus a. Here we have a vector a and a vector k times a. Now k is just a number. It's called a scalar because we scale this vector. We don't change its direction. We scale it up or scale it down. Now here k is a positive number because ka is in the same direction as a. If k was a negative number, then ka would be in a direction that's opposite to a. Also, by the way, for this vector here, k must be greater than 1 because we've scaled up a. If k was less than 1, say a number like a half, then this vector would be half the magnitude of this vector. Now here are important properties of vectors and scalars. We can distribute a scalar in through a sum or difference of vectors. No matter how many vectors appear inside these brackets, we can multiply k by each vector and sum or subtract the results. We could replace this plus with a minus sign, of course, or we could have more than two vectors in here. So suppose we have two vectors a and b like this, their tails are put together. Well, we know that to sum them we can complete a parallelogram. So this diagonal is vector a plus b. Suppose we multiply 2 by a plus b, so k is equal to 2 in this example. Well, we just double the length of our magnitude of this vector. So we get a vector pointing in the same direction but twice as long as this vector here. So I'll put the arrow up here, so the tail of it is here. So this vector is twice vector a plus b. But we could also arrive at this vector by multiplying 2 by a. So if we double vector a, we get this vector here. And then multiplying 2 by b. So we double the length of vector b. And adding the results using the parallelogram law. So we just complete this parallelogram and we get the same result. Now the next two rules are probably more obvious. If we add two scalars and multiply the result by a vector, it's the same as multiplying each scalar by the vector and summing the two vectors that result. If we multiply, well, we can just multiply the two scalars together. That's fairly clear, I think. So here are some simple examples. We can combine the two scalars here, 3 and 7, to get 10a. We can write this vector as 2 7s are 14b. And for this one here, we could actually factorize out the scalar 4. Finally, we have the concept of a unit vector. A unit vector is a vector with a magnitude of 1. So in this example, vector A has a magnitude of 3. So this is 1 unit and it's made up of 3 of them. So its magnitude is 3 units. That means that 1/3 of this vector has a magnitude of 1. So 1/3 A is a unit vector. So basically we take the vector and divide by its magnitude. So if its magnitude is 3, we divide the vector by 3. Now, the notation for a unit vector that's often used is this little hat. And to get a unit vector in the direction of vector A, we take vector A and divide it by its magnitude, or its modulus if you want to call it. Same thing as magnitude. You can also write this as A over A. You just write A with no lines on either side there. That means the magnitude of A.